This is the drifting ice buoy floating within the hole we drilled. It is connected to a wire that goes into the water. On top, there is an iridium beacon that sends GPS position through a satellite, which will give us data on the ice drift. There is also a radio beacon that is used to localize the buoy on a short range. At last, there is a flash that should blink and make the buoy visible from the ship. At the bottom of the wire we have a cage and a weight. In the cage we have two types of instruments, a CTD and a cat pinger. The CTD will collect data on conductivity, temperature and pressure. From conductivity we get salinity, and from pressure we get depth. With these variables we can calculate the speed of sound.
Here in the middle of the wire we have the hydrophone. It records sounds in the ocean like ships, marine mammals, seismic activities and so on.
We used the pinger in an exercise where we estimated the location of the buoy with acoustic signals. We lowered another pinger into the ocean from the ship and sent an acoustic signal that will be received by the pinger on the buoy. This will then return a different signal. By measuring the signal's two-way travel time, we could calculate the distance to the buoy. With several distances from certain positions, we could triangulate the position of the buoy. Not all scientific installations in the ocean can rely on GPS. Therefore, this is a very useful exercise in localizing such installations.